All right, we want to start with our unit circle. So get your packet out from Monday, lessons 1 and lessons 2. There should be an empty unit circle that we started filling in. We want to completely fill this in. We have the angles in radians and degrees. So for example, we filled in degrees and we filled in the angle equivalent for 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and back to 360 on the circle. And then we have the matching radians. And now today I want you to complete this by filling in the x and y coordinates for the unit circle. Square root of 3 over 2 and 1/2. For example, pairs with 30 degrees or pi over 6. All right, so pause the video, take a minute, and make sure you have this completed and filled out. You can write it on your notes, or you can tear out that copy in the packet from Monday to use on your test on Thursday. Also write down these notes. The general form of a sine function or cosine function, but we're going to give the example of sine function. The general form of a sine function is y equal a sine b times x minus c plus d. If we take the absolute value of a, so a is going to be what we multiply to the entire function, okay? And if it's negative, we're only going to consider the positive. Okay, now the period, we take our b and we divide that into 2 pi, and that gives us the period. The midline is an equation we get from d, whatever we're adding or subtracting to the end of that function. We're going to write y equal d. And then the phase shift is going to always be with the x. If it says minus c, okay, c is going to be positive. It's going to move to the right. If it says plus c, c is going to be negative and it's going to move to the left. All right, also today we did an assignment in study.com talking about angles that are coterminal. So if you weren't in class, make sure you complete that assignment and it's taken as a quiz grade. The first 2 attempts will be averaged for your quiz grade. All right, so for a coterminal angle, you take your original angle and add or subtract 360 to get where that angle terminates. For example, if your original angle was 30 degrees, you can write 360 plus 30, and the resulting coterminal angle would be 390. And you can also convert that to radians if you need to, by multiplying by pi over 180. All right, the first question is number 1, convert 63.5 into radians. Negative 63.5. So let me highlight that and get my pen. And we're going to multiply negative, I'm going to change that to 630. So on your review, just because it comes out a little bit better. And I don't have an answer choice here. So let's just go ahead and do it and see what we get. 630. If this is degrees, I'm going to put that over 1. And I'm going to multiply that by pi over 180. I know I need to get pi because pi tells me I'm in radians. So that's going to go on the top. Okay, and then now I'm going to put 630 times pi is 630 pi. Over 180. I'm going to start by dividing the top and bottom by 10. So I'm just going to mark through that 0. I'm going to cancel out 10. So I have 63 over 18. Now 6 plus 3 is 9, and 8 plus 1 is 9. 9 goes into 63, and 9 goes into 18. So 9 63 divided by 9 is 7. 9 times 7 is 63. And then 18 divided by 9 is 2. And then we still have the pi on the top. So I'm looking for 7 pi over 2 radians, except this is negative. So I'm looking for negative 7 pi over 2. All right, question number 2. Now we're going from radians to degrees. So I'm going to multiply by 180 over pi. When you multiply by 180 over pi, the pi cancels. Okay, so that's pi over pi, which is 1. So mark through that. And then 36 divides into 180 5 times. And then 5 times 35 is 175. You can use your calculator, multiply 35 times 18 and divide by 36. You're still going to get 175 degrees. Okay, and so I guess these answer choices went with question number 2. All right, question number 3. What is the exact value of sine 225? So now we're going to use our unit circle, and I'm going to go around until I locate 225. Remember, angles can be given to us in degrees or in radians. So there's 225. I'm going to go down, and the sine value is going to be my y value. So the sine is negative square root of 2 over 2. Question number 4. I'm going to put these notes back up here for us to refer to that I asked you to copy down earlier. The general form of a sine function, where a is the amplitude, or the absolute value of a is the amplitude. We get the period from b by dividing the absolute value of b into 2 pi. The midline we get from d, and we write that as an equation, y equal d. And then the phase shift is c. All right, so Jessica graphs a sine function that has the features listed below. It has a period of pi, amplitude of 4, and a midline of 3. So she claims this function, f of x equals negative 4 sine 2x plus 3, has all of these features. Is this the correct function for the graph? Why or why not? So let's start by pulling out a. A is going to be that first number that's being multiplied to the entire sine function. If you don't see a number, it's going to be 1. So a is negative 4, but we want the absolute value of negative 4. So the absolute value of negative 4 is just 4. All right, now we're going to find the period. The period we get by the number that's being multiplied. Where is it? It's being multiplied to the x. Okay, so that would be the b. All right, so we're going to take 2 pi, and we're going to divide this time, not multiply. Divide by the absolute value of 2, which is 2, and 2 over 2 is 1. So our period is pi. So that checks. Our amplitude checks. Now let's look at the midline. The midline we get by taking what is added or subtracted onto our function, and that's a positive 3. So we just write in that equation, y equals positive 3. And that's a check as well. Okay, so the answer is yes. It is a function because it has a period of pi, an amplitude of 4, and a midline of y equal 3. Okay, going on to question number 5. All right, I don't have the question here. I'm going to read it for you. It says that George's height above the ground as he rides a Ferris wheel ranges from 4 meters to 30 meters. So let me draw a picture of that Ferris wheel. trying, guys. All right, where's my pen? Maybe I got to pick a color. There we go. There's our Ferris wheel with a little part in the middle that holds it on. All right, so the highest it is going to be is, let me look at my question, is 30 meters up here at the top. And then from the ground, it's going to be 4 meters at the bottom. Okay, to the ground. All right, if it takes 200 seconds, so time is 200, to make one complete rotation, which cosine function represents its height, h of t, from the ground as a function of time? All right, so let's look at what we've got and break it down. All right, so we're going to start with the amplitude. It's 1/2 of the difference between the maximum and minimum. So the maximum is 30, the minimum is 4. So 30 minus 4 is, let me put that in my calculator, 26. And 26 divided by 2 is 13 meters. Let me erase some of that and get it out of the way. All right, now the frequency is B, and that's going to be our period. So our period starts with 2 pi over time, and our time is, in this question, is 200. So it's going to be 2 pi over 200. When you simplify that, you get pi over 100. All right, the phase shift is C, and what that means is moving left or right. Our Ferris wheel is not going to move left or right. It's going to be fixed. So we're not going to have a C. It's going to be 0. The vertical shift, going from down to up, is going to be 30 plus 4. We add those together. We average them. We divide by 2. And that's going to be 17 meters. So putting it all together, the cosine function representing George's height as a function is A, which we calculated as 13 times cosine, and then times the period, we calculated that to be pi over 100 plus 17. We calculated that by taking the average of the highest and the lowest. Number 6, is this periodic? So we look at this function, and I've drawn some dots to show where it looks like to me that the function starts repeating. So it's going to go from 0 to 6, one full cycle. It goes up, and then it goes down, and then at 6 it starts repeating. Up, down, and it starts repeating again at 12. Okay, so I'm just going to take 2 of those dots. I'm not going to skip anything. So I'll just take 6 minus 0 is 6. That's our period. And even if you start here, 12 minus 6 is still 6. All right, and then on the second one, it's a sine wave. Okay, so yes, it is periodic. Okay, and then it has a period of pi over 2. So I started here at 0. It starts repeating at pi over 2. So pi over 2 minus 0 equals pi over 2. Number 7, we want the exact value of negative pi over 3. All right, so if we look at our unit circle, pi over 3 is right here. But we're going down. So if we're going up 60 degrees, what's 360 minus 60? That's going to be at 300. Or 2 pi minus pi over 3 is 5 pi over 3. Okay, now we want the, let me see, it doesn't have this written down here on this slide, but on the review, we're asking for the sine of negative pi over 3. So if we're looking for sine, we're looking for the y value on the unit circle. So the sine of negative pi over 3 is down here, is going to be the y value, negative square roots of 3 over 2. Now if we're looking for cosine of negative square root of 3, negative pi over the square root of 3, okay, we're going to just take that same angle, going down this time because it's negative. Okay, and now we're going to take the y value, so that's going to be 1/2. Okay, so that's actually question number 8. Okay, number 9, what is the exact value of the tangent of negative 270? So let's find negative 270. Positive 270 is 3/4 of the way around the circle. It's right here. So negative 270 is going to go in the opposite direction. So we're going to start at 0, 90, 180, 270. Okay, now we want the tangent of negative 270. Okay, so think about your trig ratios. So, ka, toa. All right, now we're looking at tangent. And let's go to negative 270, so it's right here. Tangent is going to, we get with y over x, or sine over cosine, so that's going to be 1 over 0, and that is undefined. Instead of me trying to write it, let me circle it up here. Okay. Question number 10. A sound wave can be modeled by the function f of x equals negative 2 sine 4x plus 1. What is the amplitude of the function? Okay, so let's think about what amplitude is. We took those notes down. Amplitude is going to be right here. That's going to be our A. But it's going to be the absolute value. So don't get in a rush and put negative 2. Think about the absolute value. The answer is positive 2, not negative 2. Number 11, which of the following angle is not coterminal with the other 3 angles? So what we're going to do is we're going to take 17 degrees. Let's find that first. So 17 degrees is going to be somewhere between 15 degrees is halfway. 17 degrees is going to be more up here somewhere. So it's not one of our special angles. Let's just get a reference point. Okay, now we're going to take 360 and we're going to subtract 163. So 360 minus 163 is 197. All right, so those don't match up. 197 is going to terminate over here somewhere. All right, now let's look at negative 197. So let's take 360 and we're going to subtract negative 197. So that's like adding 197. And you subtract from 360. Okay, so we're going to get 7, 15, 3, 4, 5, 557. Now let's start going backward. 557 minus 197. I messed that up. Let me erase that. It should be 557. Hold on, eraser. It should be 557 minus 360. So when you subtract 360, you get positive 197. And that's a match. Is that right? Positive. And then 360 minus 197 again is 163. So this matches with this one. And then 523 degrees minus 360 is 163. So these three match up as far as terminal angles. This one is the one that's the odd man out. Question number 12. We have tangent of 8 over 15. So tangent is opposite. Let me write that down. Get my pen out. Oh, I have it written down here. Tangent is opposite over adjacent. All right, so we don't have the hypotenuse. Okay, so this is H. We'll make one of these opposite, and we'll put our angle right here. We'll call this theta. So opposite, the tangent would be 8, and adjacent, what's right next to that, what's making up that angle, is 15. Okay, so that's what we have. We need to use the Pythagorean theorem, a squared plus b squared equals c squared, to find the hypotenuse. A squared plus b squared equals c squared. A is, let's make A 8. 8 squared is 64. Let's make B 15. 15 squared is 225. 225 plus 64 is equal to, get my calculator out, that's equal to 289. And the square root of 289 is 17. So our hypotenuse is 17. So now that I have the opposite, which is 8, the adjacent, I'm going to go ahead and put an O for opposite, A for adjacent, and H for hypotenuse. Then we can write the sine, because sine is opposite over hypotenuse. So that's going to be 8 over 17. That's going to be D. Okay, question number 13. A particular sound wave can be graphed using the function y equals sine 3/4 x. Find the period of the function. So we're multiplying, what are we multiplying by x? We're multiplying by 3/4. So we're going to start with 2 pi, and we're going to divide by 3/4. When you divide by a fraction, you're going to flip that. So I'm going to flip that and turn it into 4 over 3. And then I'm going to multiply that by 2 pi, or 2 pi over 1. Okay, so 2 times 4 is 8 pi, and 3 times 1 is 3. So I'm looking for 8 pi over 3, so that's going to be A. All right, one more question. I think one more. Okay, 14, what is the equation of the graph shown below? So we have a sine wave, okay, and then the general form of that equation is y equals, again, A is the amplitude, B, if you divide that into 2 pi, is the period, C is the shift, and D is the, we call that C phase shift, and D is the midline. We write y equal D. All right, so let's start with f of x. All of these are f of x. So f of x equals, now let's take, we've got to calculate actually the period. So let me take a point here. We go from 0, we go up and then down, and then we start repeating right here at 2. So 2 minus 0 is 2. So we should be multiplying by 2. And these right here are multiplying by 2. That's our A. So we can cross out A and B. Okay, now we've got to calculate the period. So 2 minus 0 is 2. So we're going to divide 2 pi by 2. Okay, when you divide 2 by 2, you get 1 pi. Okay, so it should be sine times 1 pi x. So it's going to be C. Okay, we don't have a phase shift, or we don't have a y equal. So we're not moving it up or down. Okay, that's it as far as the review. Make sure that you have this written down for your notes and go look on your test.